Welcome. We are going to look at section 2.3 today. On the first day, we mainly concentrated on the product rule. Today, we're going to delve into the quotient rule. So that's where we're at. However, if you recall, I didn't finish the last example of product rule. And this is an important one to cover. It covers the fact that what if I have more than two factors? So here you can see I've got one factor, a two factor, and three factor coming into it. How do I apply the product rule to something like that? Well, you'll notice here, here's my first item, my f of x getting the derivative. Here it is the second factor getting the derivative. And finally, I have the third factor getting the derivative of it. So you'll notice that each of the factors ends up getting a turn of having its derivative taken. And so if I look at letter E here, I hope you can spy that there are really three factors being multiplied here. Sometimes it helps to insert the parentheses and then it's more obvious. But I'm going to take the derivative y prime. I'm sure we'll get a long string of terms here, so leave lots of room. The derivative of the first is what I need to do. Let's take the derivative of the f of x factor. So I'm going to have 2x as my derivative, multiply it by the second and the third factor. So sine x and cosine x. Then it says to add, so we'll put a plus sign down. I'll take the first term and the last term and leave them as is, or factors, leave the first factor and this third factor alone. It's the middle factor I want to take the derivative of. So you can do this however you want. I think I'm going to take the derivative right now, and the derivative of sine is cosine, and then I multiply it by my other two factors, leaving them alone as they were originally written. Now I'm on to my third step, and what we notice here is we need to take the derivative of the third factor, leave the first two factors alone. So I'm going to go ahead and take the derivative of my third factor just so I don't mess that up. And the derivative of cosine is equal to negative sine. I bet you thought I'd forget the negative. Let's see, we got negative sine, and then we're going to multiply it by the f of x factor and the middle factor, g of x. So there's my sine x. Now it's really going to be a matter of simplifying. And I noticed as I was writing some of those others down, I think there's some combining that can be done. For instance, we've got a cosine times a cosine. That's going to give us a cosine squared. And I'm leaving just a little bit of room because I'm going to write x squared in front of that. I think it looks just a little bit clearer to have it that way, rather than putting my x squared at the end, because then it's a question like, okay, is the x squared inside with the cosine or is it outside of the cosine? So write it in front and it clears up the ambiguity. That's a hard word to say. All right, so I've got the negative x squared that I'm going to bring out front, and then I notice I got sine squared x as that term. And you know, there's a little bit of cleanup. There's not a lot of cleanup on this. You could pull an x out forward. What I was thinking was perhaps cosine squared and sine squared. We know there's a Pythagorean identity that would give us 1 on that, but with the minus sign in there, that's going nowhere either. So I think we've hit our result right there. So let's talk more quotient rule. Quotient rule, of course, it has a formula to lay out and follow when we're doing it. So I have my top factor of my fraction is going to be called the f of x function, and then I've got a function down below, the g of x. So just like in product rule, we're going to follow through the symbols here. So I take the derivative of f of x. Well, that was my top fraction, or the top of the fraction, the numerator. And then I multiply it by the denominator. So it's the derivative of the top times the bottom minus derivative of the bottom times the top. All divided by, now look at this bottom here, it's just g of x getting squared. Not g prime of x, it's just g of x. So derivative of the top times the bottom minus derivative of the bottom times the top, all over bottom squared. I kind of relate this to when I did the product rule. I had you guys do it in this fashion. Derivative of the first times the second plus derivative of the second times the first. And notice how the layout is the same exact order, f prime g, and then instead of a plus sign as in the product rule, we have a minus sign in the quotient rule. But otherwise, the layout is virtually the same, only we've got a top and bottom. Some people do memorize it. You'll find you might have teachers that say low d high minus high d low, and low d high stands for the low g of x, here's my low, times the derivative, the d high, so derivative of the high, minus high, here's my high, which is f of x, times the derivative of the low, so d low, all over low, low, or low squared. So if you want to memorize it that way, that works too. Low d high minus high d low, all over low, low. All right, so let's try one out. So identify, if it helps you to identify, there's your f of x, here's your g of x, according to the rules. And so we have a function labeled here f of x, so don't get confused by that. F prime of x equals derivative of the top, so we're taking our f prime of x. So that's going to be a 7x to the 6th multiplied by the low, no derivative of the low, so 3x minus 2. And then minus sign, different than the product rule, minus sign. And then I do the derivative of the bottom, which is 3 times the top, no derivative of the top, just as is, there's x to the 7th, all over low, low, or g of x squared. So 3x minus 2 quantity squared. And let's just simplify. We've got the basics laid out. We've done the hard work. Now it's just cleaning it up, a little bit of algebra involved. 21x to the 7th, add our exponents, minus 14x to the 6th, minus 3x to the 7th. And then the bottom, I am going to leave it in factored form rather than expanding that out. Sometimes you can get some cancellations to happen. And it looks like we have one more step of simplification. I've got x to the 7th and x to the 7th on top. So 21 minus 3 gives us 18. X to the 7th minus 14 x to the 6th. And then over our bottom, squared. Now on top, you definitely could pull an x to the 6th, and you could also pull a factor of 2. So I'm going to go ahead and do that just to kind of finalize and get this in factored form on top. If I pull a 2, that's going to leave me a 9x minus a 7, all over 3x minus 2 quantity squared. And I'm just kind of taking a peek. Is there any chance that these would cancel? Well, not on this one, but sometimes that is possible. All right, moving on. G, so G is G of t, and then it gives us t squared plus 2 over 2t minus 7. Why don't you give this a try on your own? We could hit the pause, and then you could try it on your own. So what did you do? Well, I hope you did derivative of the top times the bottom. So that would be f prime of x times g of x minus g prime of x, or the bottom, the derivative of the bottom, times the top, all over the bottom squared. Simplifying, hopefully you did some simplifications. And don't forget to run that negative through. Oh my gosh, so many people make that mistake. Drives me crazy. All right, and organizing. I'm just double checking my work before I move on. Oh, a good thing I did, because look what I forgot to do. 2t times 2t gives me 4t squared, the minus 14t, negative 2t squared, and a minus 4. Okay, now I'm ready to combine. Gets me a 2t squared, a minus 14t, a minus 4, all over 2t minus 7 quantity squared. On top, I notice I could factor a 2. If I factored a 2, is it factorable once I pull that? I'm not sure. All right, so that doesn't look very factorable to me. So they're not a big advantage to factoring it other than to check to see if these three terms would factor, but they do not. So you could leave it back there. H looks a little more complicated, doesn't it? But it's still going to be the same rules. Derivative of the top times the bottom minus derivative of the bottom times the top, all over bottom squared. So y prime, derivative of f of x. So I'm going to have a 3x squared plus 3 multiplied by the bottom, g of x, minus derivative of the bottom, that's a 2x multiplied by the top, all over the bottom squared. And then some fun foiling for us. And I'm going to hit pause. You can hit pause and go ahead and foil that out. Okay, so this is what I got for the top. You double check. Now it's really just simplifying this out. And what do we have? 3x to the fourth minus a 2 gives us an x to the fourth. A 3x squared and a negative 3x squared makes 0 of those. So these are going to wipe each other out. Oh, and then we have this minus 6x squared. So I got a minus 6x squared and a minus 4x and a minus 3. Does that take care of? There's my fourth power, my squared power, my single power, and a minus 3. Got it. All over x squared minus 1 quantity squared. And I don't believe that's going to factor up on top to give us any result with canceling below. Finally, number 70, find an equation of the tangent line to the graph at the given point. The graphs in exercise 69 and 70 are called the witches of Agnesy. And these graphs and then you have to read the rest of the book, I guess. So here is the function. Maybe it looks like a witch's hat, huh? Okay, so here's our function. F of x equals 27 over x squared plus 9. And they want us to write a tangent line through this point. So if you want, why don't you just sketch in your tangent line? I envision my tangent line sliding through underneath where it's touching that point in one spot. So that is just skimming that point. Let's go into our derivative. F prime of x equals low d high. You want me to do it that way? Low times the derivative of the high, which is 0. Ooh, that's going to 0 out. Minus derivative of the bottom, 2x multiplied by the top, 27, all over bottom squared, x squared plus 9 quantity squared. Simplifying, well, our first term falls away because of the 0 multiplier, and we get equals negative 54x all over x squared plus 9 quantity squared. Now they ask us to write a tangent line. In order to write the tangent line, or write the equation of the tangent line, I need to get the slope at that point. So let's analyze the slope at x equals negative 3. Now this is an instantaneous slope because we're at a point, not an average slope over 2 points. So we want f prime of negative 3, and we will pop that into our equation, which is our derivative, right? Negative 3 is getting squared, add 9, and then square that result. Okay, 108 plus 54 more, 168, 162 maybe, huh? There's a 2, carry a 1, 162 is going to be positive, over 9 plus 9, 9 plus 9, 18, 18 squared. Oh goodness. Well, think about that, 18 squared. 324, there's that summertime buzz. coming, summertime fog maybe, huh? 162 divided by 324, we get 1/2. So now we know our slope. We know f prime of 3 equals 1/2. We also know the ordered pair. That's kind of nice. We don't have to go find the original y value by plugging in x. And then you're designed to write the equation. Y minus y1 equals the slope 1/2 times x minus -3. That's going to turn into a +3. And you may leave your answer in point slope form. Your homework looks like problem 7, 11, and so on. You should be able to get this worksheet handed out to you because I printed it for you. All right, have a great day. I will see you on Tuesday. Bye-bye.